Okay, so I lead a small team here of PhD economists at eBay, and we focus on a variety of wide-ranging economics questions relative to eBay, which, as you might imagine, is pretty much everything eBay has to worry about, because eBay's sole business is running a giant marketplace, right? So we think about market design questions, auction theory, auction design, bargaining, best offer, which is our bargaining platform. We think about marketing a lot. We think about trust and reputation, which is basically just game theory about a feedback design. So we think about all these random things. We haven't historically spent a lot of time on search, because search is actually something I believe eBay does extremely well. And so I haven't really felt like I could add a whole lot of value to it. So this is mainly actually aimed at another audience. This deck and this presentation is really largely based for economists, because economists know almost nothing about search. And so I'm hoping to get some feedback from you guys about what we might be missing here and what we might be able to add to our understanding of search. But at the same time, economists have a particular perspective, and so I'm hoping that we can kind of show you the way that economists think about search, and some of the open questions and problems that we have, and some of the descriptives of the data that we find really interesting and relevant. And you might find this different perspective a little bit entertaining, if not shameful. The other thing is, I come from economics, and I know that in a lot of computer science professions, it's really polite and considered expected to hold questions until the end and then politely ask them. Economists are jerks. They're used to being yelled at. So if you have any problems, questions, objections, or just concerns, raise your hand, just speak up. Go ahead and interrupt me live. I'm used to being interrupted. My wife will attest to that. And so if I say something out of place, please just speak up. Okay, so generally, how does an economist think about search? Well, economists have been thinking about search, at least from a theoretical standpoint, for quite some time, going back to at least the 60s. Plagued by technical difficulties today.
What could possibly go wrong?
Yeah, I know. I feel like there are gremlins about. So they all just come back to life. It did not come back to life. There it is. So how does an economist think about search, right? So the simplest models of search were basically just, let's think of a bag of items and users are going to choose one, right? So this is what we call fixed sample simultaneous search, right? We're going to take all the items that a user might consider buying. We're going to put them in a bag and say rank them by characteristics, and one of the characteristics, of course, most importantly, is going to be price, and the user is going to choose the most important one, right? So in that kind of framework, then the most important kinds of questions are ones of how do I identify what we call the consideration set, the bag of items that people might be thinking about. But in the 70s, this started coming along and realizing that actually search isn't that simple, and we started thinking about sequential search problems, which is actually basically just an optimal stoppage problem, a dynamic model, which is, I think in the computer science literature, often called something like the secretary problem, right? And the way we think about this is searching is costly, right? These models are from the 70s, way before the internet existed, so what we think here about searching is I have to go find a particular item, say I want to buy a new couch. I now have to go to a store, find out what the couch is like, find out if I like it, find out how much it costs. Well, that store only has a handful of couches. Now I have to go out and find another couch. I go to the next store. That takes me an hour, or so on and so forth. So we can think about incurring a cost for every phase in the search. And then at some point I'm going to decide to stop searching and just buy from the ones I've seen, right? So what we think about is a consumer assigns a set of valuations, which is going to be, think of valuations xi for every item they might consider buying. Hopefully that won't fall over. Where vi is going to be the intrinsic valuation, so this is how much you like that couch, and pi is going to be the price, which is how much you dislike buying that couch, right? Because you have to pay for it. So what you can think of then is they're going to basically build this vector of x's, and they're going to keep going as long as the expected gain, the possibility of me finding a set of couches out there that's better than the ones I've already seen, is positive, right? And so that's where basically all the models get really interesting, and they build these giant rules that are based on the distribution of valuations, distribution of prices, and figure out where consumers are going to stop and buy. So some of the implications out of this stuff are really quite obvious. But really everything focuses on the search cost. How much is search going to be? And it turns out, of course, that the higher search costs are, the less searching you're going to do. Okay, duh, we all kind of figured that. There are other more interesting stuff that economists have actually really focused on because they're more relevant for policy. It turns out that actually as search costs go up, firms start responding in particular ways. Basically, they'll increase the distribution of prices because now they know that it's really a pain in the butt for you to go and find that next couch, so they're going to increase how much they charge how much they charge you for that couch. And so suddenly average prices go up, price dispersion goes up, and firms start exerting market power, right? So along comes the internet, And suddenly, economists have realized that search is actually an extremely messy process. And at first, economists basically focused on the fact that, hey look, the internet is this great tool, it makes search really easy. Now I can find thousands of couches online simultaneously, that's fantastic. But actually we know that it's not that simple, right? It's actually not totally costless for me to evaluate every possible couch that's listed for sale on the internet. I have to spend hours and hours of time doing that. And so while the search costs have come down dramatically, it's not quite clear what they are in an internet setting. And so economists have started approaching how to answer that, right? So they started with easy things, and they started with largely unrealistic but very tractable settings for known goods, right? So things like searching for books. I think it's quite possible the reason we started with books is because Amazon was a bookseller and there was lots of data about book prices online early on the internet days. But recently it's been expanded to hotels and other kinds of things, and here's some literature that basically actually looks at these very tractable known search problems, right? So we're not talking about places like eBay where you have a complete litany of types of goods to purchase. We're just talking about, I want to find a hotel in a given city at a given weekend. My options are finite. How many pages do I go through on Expedia.com or something like that looking for the right hotel?
Why are you heading this direction? Because you're spending, you seem to be making a model. I assume it is a model to try to describe what customers see from the search perspective, but yet you work for eBay, when I assume that they're actually trying to find out how they optimize their work. What are you trying to get out of all this?
Fair question. My main reason for doing this, as I said, was basically to inspire economists to think about what real search is supposed to look like on the internet in a realistic setting. I'm not actually going to build a model. I'm going to tear a bunch of these models down. So these are the bunch of models that currently exist. They're giant structural models. They're basically very sophisticated mathematical tools to try and estimate a search cost parameter. And the reason they do that is because they focused on these tractable settings with very limited data. eBay has a lot of data. So I'm just going to basically describe a bunch of data that impugns the results out of these models. And the reason for doing that is just trying to, one, figure out how much users actually incur costs. And one of the things I'm trying to do today is trying to show you that users actually incur relatively small costs in terms of search, which in terms of eBay's interest has particular implications for how we design our search engine. But there's also just kind of a framework of how to think about search and what dimensions users are searching over. I'm just going to describe some of the data that fits there. Does that make sense?
Okay, there's no optimizations that you're trying to go after.
No, very different kind of talk than what a machine learning talk might think of. I'm not going to build a model. I'm not going to try and convince you I'm optimizing anything. I'm just going to try and convince you. The one parameter I will try and convince you on that was hinted in the abstract is what search costs are. So I have a giant estimation where I'm trying to estimate what search costs are, and I can basically show you they're pretty small, especially relative to these, right? So the existing literature out there that builds these giant structural models basically estimates what search costs are. And they come up and say, consumers don't search very much. And I mean, these guys say consumers don't search at all. Like they search very, very little. And that then implies the search cost, the penalty I incur for trying one more set of items is extremely high. And I mean really high. So taking some quotes out of some of the recent papers, somebody who looked at hotels, which I don't think they quite say this at Expedia.com, but it's probably something like Expedia, where they basically estimate this model and they look at the data, and then they impute how much users would have gained if they had searched one more page. And then they basically back out the cost, and they find that it's something on the order of $10 per page, which basically means given what we estimate demand to be, if users had clicked the next button on the search page, they would have gained $10 in valuation, which means they didn't click next, which then you impute to say, well, it cost them $10 worth of time, effort, and hassle to click next and look at one more page of results. That seems ridiculously high, but that's what these papers are, which are the cutting edge of the economist's work, are saying. Other settings in something like books, I'm sorry. So first, the problem with this, of course, is data shortcomings. And they're upfront about this in the paper. So the problem with these models is they're dealing with tractable settings because that's where they have data from. eBay has a lot better data, so that's what we're going to try to do today. But basically, this data has shortcomings in the sense that they don't actually observe final outcomes. They don't actually observe purchases. Here at eBay, of course, we observe both the search and the purchases, so that's a nice setting for us. But also, they don't actually look over long periods of time, right? So the existing models only ever look at search within a very short window. So you asked me what I thought this might be relevant for eBay. I don't know about the rest of the search industry, and I'd actually be curious to see what people think. But typically at eBay, people think of search as being a very short-run thing. I'm within a 30-minute window or something, I'm in a given session, I'm at my computer, they think, am I going to find is the user going to find what they're looking for in one session and buy it at that time? And in fact, what I'm going to show you today is it's not that simple. Users search over a long period of time, and their search practices evolve over that period of time. And so we have to think about building a long-term search engine. That was the main pitch I had for eBay, to be honest. Yeah.
So I'm a little confused. Is this from the user perspective, that $10? Because that seems more like a value as opposed to a cost.
So this is the nice thing about economics. They're basically inferring one is the other, right? So the cost that I would have to incur is then going to be the value. And the reason for that is because it's just a revealed preference argument, right? The theory that otherwise the prices on the next page would have been lower to the effect. So I guess the scary answer to your question is yes, it's both. And that's just kind of the way economics models tend to work. But basically, you infer that if the gains from doing something is $10, then I'm willing to do exactly that. And if I weren't, it would arbitrage away. Does that make sense?
But it seems like these, search engines are getting a small percentage or some other valuation than what the customer is paying for like a hotel, right? So
That's a fair point, which is basically if this estimates were actually true, then the search engines are leaving a lot of money on the table and not doing the jobs very well. That's an implication of these papers that I hadn't thought of before, actually. But yeah, no. So the big problem with these papers is they're only looking at short-term windows. There's another paper looking at books, which basically says, okay, now we're talking about $2, $1 per search. That's at least something more reasonable. But here they're looking at only 7 days up to for any given search, so it's a little bit better than the 1 day, but it's still pretty large effects and may not actually fully capture what's going on. Okay, so in contrast here, eBay, I'm gonna put together 3 different data sets that kind of tell a story, which is one, we find that people search a lot, right? So we actually see users searching across a wide range of products, even for a given search intent. And then they actually search for the same products over and over again in a sense to look for better prices, right? So there's 2 different dimensions people might search over. There's product characteristics, they might be trying to figure out what they want, and then they're trying to find the right deal because prices change over time, market conditions change over time, and there's different sellers, different inventory, different times, right? So part of that then basically says the users have to search over a long period of time in order to find the right deal. In fact, we see that. I basically build a panel data set to kind of describe how long that is. And then finally, if I'm not going too late, I'll talk a little bit about some of the stuff I've learned from looking at all the search experiments that eBay does, which is probably not anything new to you, but it's kind of interesting to us. Okay, so this is what a search results page looks like at eBay, which I don't think would surprise anyone in this room. If you haven't heard of ebay.com, this is what you'll see, or at least this is what you'll see when I did a screen grab when I started this project a long time ago. Okay, so the first this is just a motivational slide, but the first kind of thing that we think about people doing in terms of search, as economists, we think about price search, right? Like in the couch example, what I'm thinking of, people are looking for the best deal. So here's an example where you actually see somebody trying to find the right price for a given item, right? This is a user, what I've done here is basically just had, the blue line is the query that some user entered. These are all the item titles that the user then viewed, click on the view item details page. And then the green is what they actually the item title of the item they wound up buying, as well as the price. So this user searched tin cup, and basically then looked at a whole bunch of versions of the tin cup DVD, slightly different descriptions. And then one thing you realize, these are all used DVDs, but they have a huge range of prices, right? So maybe some are scratched, maybe some are from people with high valuations, you don't know. What you think is, if they're searching for all of these, this just makes you realize they're going through lots of very similar types of items, and they should be just looking for the cheapest price. But then at the last minute, the one the user actually buys is the most expensive item on the list, right? So this is their first insight into thinking, well, wait, they've looked at 6 or 7 items that are all exactly the same. You think that they're getting cheaper and cheaper. In general, they kind of find cheaper items, but then at the last minute they buy something that's actually a lot more expensive. And the reason for that is because it was branding. So even though we looked at a bunch of used stuff, they eventually said, okay, maybe all of the items that I looked at were cheap, but maybe they were all kind of scratched or dingy, and so I decided to buy a brand new one and pay a premium for it. So even though the user was initially searching over price, they wound up switching over to something completely different than they were originally searching for. Please.
How do you define the click and see the details page, or just it was shown to?
Click and view the these are clicked through the search results page to view the item detail page. Right.
Now, it's not as apparent on eBay, but with Amazon, you see that there are lots, like even for Tin Cup, there might be a version with special edition version and there are still widescreen or whatever. So people are looking around, using their search in order to find out what's available and what differences there are. And
Exactly, perfect segue to my next question. So here's my next example, which is the messiest version we can think of finding, just so kind of you can understand what's going on, which is exactly this. So this person searched a very broad query, doesn't quite know what they're looking for, they just searched opera DVDs, and it just so happens the first item they clicked on, right here, is the item they wound up buying eventually. But they didn't buy it right away, they actually then started browsing around, right? So they went back, they searched opera DVDs again, the first thing they look at and bought is Puccini, but then they went back and they found, I don't know, something German. Then they said no, they went back, they said opera Verdi, and then they looked at a whole bunch of Verdi, I guess, they looked at a whole bunch of Verdi options, said no, none of those will work, tried again, didn't like those, that search results page, refined the search to zoom back out, went back out to opera DVDs, right? So suddenly they're searching for opera DVDs, then they narrowed the choice set down to Verdi DVDs, and then they said no, never mind, and went back out to all opera DVDs. Again, looked at the one that apparently had first actually appealed to them, said nope, still not, tried an entirely different name, a different opera I suppose, looked at 6 of those versions, no, still try another search, okay, maybe even a 7th version of that, no, maybe not, switched over to Wagner, now we're into a completely different composer, 3 versions of that without viewing anything, I guess they didn't like this on that page, so on and so forth. And so eventually what happens then is then they start bouncing back and forth between the search page and the thing they're eventually going to buy. So on the one hand, this is an eBay search win because what they eventually bought at the end of the day is what we first showed them right up front. But they weren't happy with that. And so they just kept going because they weren't sure what the entire consideration set looks like. So this kind of fits with the sequential search model, but it doesn't fit with the sequential search model over price because what they're actually doing here is trying to figure out which one they like. There's a huge range in prices here, and the cheapest ones they looked at were nowhere near what they actually bought, but there were some that were even more expensive, right? So it's not clear exactly at what point in time users searching over a product or searching over a price, but it's pretty evident from just this one example that that evolves over the course of a given session, right? This is just within one session. So let me talk a little bit about more generic, kind of site-wide metrics, looking at just within session behavior. So just the kind of idea of are users refining what they're searching over during a session. So what I did is basically pulled all user activity on a given day, July 2014, and then basically just said, okay, how much do people search? Maybe this doesn't surprise you, but just for background, people search about 10 times per session. They search over about 2.5 product categories, which actually means they're browsing on average over a fairly wide range of items, but not over the entire universe of eBay's offerings, which is not terribly surprising. The average query is about 2.5 words. They go up as high as 4, and only 15% of the people actually searching in the sample made a purchase. So that means most people did a lot of searching, but didn't buy anything. So this is kind of indicative of browsing behavior. So we use the word search to describe all the stuff, but people aren't searching so much as they're browsing. Right? So, okay, that's kind of the idea. One of the things that comes out of browsing is this idea of refinement, right? So this is just some data showing here for each plot on the x-axis is the minute into the session. So from the first time we see that user arrive, looking 30 minutes into the activity on the site on that given day, just counting up what's happening, right? So the first thing we see is most sessions, die off fairly quickly. So most people are here only for a minute or two, but 30 minutes in, there's still a fairly mass of people that are actually still searching even 30 minutes into the session. One of the things I find most interesting is the number of words in the query by minute. I think this is really kind of interesting. You kind of have to squint a little bit, and it's kind of a noisy process because basically there's a lot of volatility and noise in the average of number of words queried. But basically what you can see here starts off fairly low, it jumps up in the first couple of minutes, and then it drops back down again, which I kind of take very much straight from that opera DVD example where basically people are searching for something they kind of want and then saying, wait, no, never mind, and they're jumping back, right? So they're not adding words, they're removing words from the search query. But then as you go further and further in, on average, they're adding more and more words.
So for the root interruption,
Please.
it doesn't go up very much.
No.
And you're talking about the average, and so the distribution is important too, and so how can you conclude anything from that graph?
I can't, and I'm speculating here, because if I were to put in error bars, they'd be like this big, right? And you're talking about a really small, I mean, you're going from 2.8 to 2.6,
I mean,
right? So,
personally, I would stare at that graph and say, wow, the average actually didn't go up very much if it went up at all.
right, and statistically speaking, it didn't. So if you're running just an OLS regression for this, you don't get a positive slope, right? So you don't get a statistically significant positive slope. I was going to caveat all that, don't worry. But yes, this is something, if you squint, you start to see this stuff, but you kind of have to want to see that it's there.
Yeah.
Some of these other results are much more striking and convincing. This one I really like, which is the default ranking. At eBay, we call it default ranking best match. This is basically what the search team thinks people are looking for. But of course, you can sort by anything you want. So you can just sort by price. You can sort by time in these series for items, or you can search by a bunch of things, right? But basically, the most common, of course, is the best match, which is the mix of what we think you're looking for, given the search intent, and the price, trying to give you what you're actually trying to get. But then once you narrow down the search query substantially enough, you can just sort by price, lowest to highest, and find the cheapest item of the things that you're thinking about buying. And so you might imagine that you're going to do that once you decided exactly which item you're going to buy. Then you're going to sort by price. And in fact, what we see here is this is the fraction of people who are sorting by best match, which means that the remaining fraction are largely sorting by price, and that just drops as it goes into the session. So this is kind of evidence that maybe it's a sequential process. People search over product characteristics first, and then they search over price, but that's conjecture. I don't really have any direct evidence on that point. But I do have evidence that people are actually more likely to sort by price later into the session, which is interesting. So this is just kind of flipping on its head. This is the average price of all the items that show up on the search results page. That looks really flat, even to me. Probably looks really flat to you. But basically, there's no real evidence that the price of the items viewed during the session get cheaper, right? So even though users can refine the kind of price of the items they're looking for by adding, say, the word used to any search query, you're going to dramatically drop down the price. They don't seem to be doing stuff like that. Instead, they're kind of just zeroing in on what they want and then doing sorts, right? So this is just the purchase volumes. This kind of actually starts off really high, which suggests a lot of people actually buy really early, but then they're buying later on, so and so on. This is the price that people are buying. This is normalized for IR approval, but basically what you see here is maybe some negative trend, but again, noisy enough that you're not really going to actually get anything inside that.
Could you say this is buy it now or bidding?
Would I say which is buy now? The purchase?
Well, like the price, I mean, were they bidding on a price or was it a buy
So
it
it's a
now?
fair question. The average price viewed is the buy it is only the fixed price inventory shown. I took out the auctions because you don't see the
right,
final
just
price
wanted
there.
to make sure.
And this is the total transactions, whether it was a. No, I'm sorry. This is only the buy now. Yeah, thank you.
So
The purchase
what
one
is,
is also.
sorry, what is the purchases graph saying? The number of purchases happening in the second minute of the session is the peak? Or
Yes, which could be a lot of things. This one could be people coming back to actually buy something they had browsed before, right? Maybe they got an email or something. Don't really know, but yeah, purchase volume actually seems to, per user, spike in the second or third minute. It's pretty hard to buy something within 60 seconds. A lot of people manage to do it, but then it just drops off as things go down. So I don't really know what to make of this in terms of search, except that for completeness I thought I'd show it. Okay, so this is actually some work taken from another paper, which gets at the same idea of refinement. I think it just kind of bolsters the idea this is not just an eBay particular problem, because you might imagine there's a lot of things about e-commerce, about eBay specifically. Maybe we have too broad a set of items, so people have to do a lot more product refinement. And actually, in this paper, they've narrowed it down to one of these, quote, clean settings. They're just looking at DSLR-type cameras, and they're looking at people searching across platforms. So they're using the ComScore data, basically, and they're looking at Amazon and eBay and all kinds of other settings. And what they find here is over the number of searches, this is the distribution of the estimated price that they're looking at for the items they're eventually going to buy. And what you see is that basically the prices just kind of narrow, but they don't evolve, right? So as people are searching more and more, you don't actually see them finding the better deals. They just kind of narrow in on the items they're eventually going to buy anyway, which again fits with that kind of the opera example, that maybe this idea of refinement isn't actually finding the cheapest option, it's just kind of narrowing out all the options of the things they don't want. So that just makes life really difficult for economists, because now we're in a world where price doesn't matter that much. It's just kind of frustrating for us. Okay, so the second thing I did basically is we wanted to really dig into that long kind of horizon, long search horizon. We wanted to understand how much search do people do over time. So the best way to do this is to actually use eBay's data and connect users over time. So I started the seed day on a particular day. I looked at everyone who showed up and did any search at all on that day. And then took a random sample out of that, just to kind of reduce the numbers of 500,000 users, and then followed all of their activity for the following 30 days. Right? So what I find then is over that 30-day period, they basically, on average, users bought about 4 items over the 30-day period. Okay, mine seems about right. But they did 144 searches over that period. So that's a really high search to purchase ratio, right? People are searching a lot before they buy. So this is our first hint that maybe all those previous models that were limited data are kind of underestimating how much search actually happens, and so therefore they're overestimating search costs, right? So then some other things here. One of the things is they spent 11 days searching, so which means 11 distinct days over the 30-day period searching on average, and then they repeat the exact same search on average 3.5 days, distinct days. So this means people are actually searching for the same item over a long period of time. And so some evidence of that is over the 30 days, this is the distribution of the number of distinct words divided by the total number of words done. And basically what you can see is that most people are searching fairly often for the same term over and over again, right? So there's not a lot of originality here. They're not searching for a new thing every time they show up. They're searching for a lot of the same thing over and over again.
Is there an accounting for the follow search feature of eBay where you can, you can follow searches would have you searching for the same thing over and over again?
So the follow search sends out an email, and if you click on that link, I was told at one point that wouldn't show up in my data the way I queried it. But I think if it triggers people to come back to the site and then search, as an economist, just think that's another search.
I never have the email sent to me, but I do go and say, this is my followed search. Go look again.
Oh, well then yes, then you'll get the SRP, you'll get the search results page with the list. That would show up.
Tend to make your variance very small.
Exactly, that would skew everything down to this way. And I think of that as part of what I'm trying to capture. So you're right, in part we're enabling this behavior, but users seem to like it and use it, which is why we enable it. But this is the point, is that people are following the same search over and over again because they're looking for, maybe they're looking for deals, maybe they're looking for, I would hope that they're looking for deals. That's probably the best economic explanation for using it.
So one thing that's unusual about eBay search is that a lot of people use the facets.
Facets meaning the filters?
Left rail.
Yeah.
Yeah.
So, and in most search systems, nobody uses the facets if they're available at all. So you're only looking at words and not facets in that analysis, right?
That's a good point. I should. So you're right, I could define repeat searches as looking for the same queries and filter conditions.
Because some people actually do narrow using the facets, right?
I should.
So,
Yeah.
For sold prices versus actual current prices.
Yes, so the disconnect between list prices and sold prices is some other work that we're doing, because economists generally can observe list prices, but don't always observe transaction prices. And so you're right that those are completely different things, which is why I was reporting both of them independently earlier. But that's a whole other conversation in terms of the disconnect between inventory and market clearing prices. Yeah.
What about collectors who are looking for a broad range of products and multiple times?
That might be another explanation for what's driving this, exactly. And I think of those as collectors are people with very low search costs, right? Like this is, if you watch the HGTV stuff, these are people who go around just constantly looking for stuff to buy. Now, why are they buying it? They're not necessarily buying it for consumption, but none of these search models imply that you're buying this for consumption. You might be buying stuff to resell, right? But collectors are people generally with very low search costs who just go around finding the deals because they have an advantage, right? Somebody like me, I'm lazy, I don't want to do a lot of searching. I'm not going to go looking for stuff to arbitrage with somebody who loves searching for stuff that has really low search costs. They're going to have a better competitive advantage in arbitrage. So yeah.
Did you take into account that filtering or reordering is counted twice or once?
I'm sorry, I don't follow. So
if you resort it, then it's a different query, same query with different conditions.
good question. I don't remember. That's a good question on whether or not I deduped for sessions, and I think that depends on which table I was looking at. In some sense, you're right, that would be double counting the repeats, or over counting the repeat search, but you're not going to hit it 4 or 5 times, so it might only happen once or twice per query.
Who knows?
Who knows? But yeah, okay, so one answer to that is actually, that doesn't happen across days, right? So the other thing I really was shocked by is how often people are searching for the same item over the same days, which is what this plot is about, right? So here, basically, I took that same sample, this is the same sample, all the seed date on the same day, people who searched, and then looked at the blue line showing what fraction of those 500,000 users bought something on any given day. And you can see there's generally more people buying something in the couple of weeks after that seed date, because I conditioned on them showing up and shopping, so they're more likely to buy. And at some point, you hit just kind of our general baseline active buyers buying these peaks or Sundays, basically, more transactions on Sundays. What was really interesting is the red line is the fraction of people who are repeating one of the searches they ran on that seed date, right? So I could be in a given session double counting people who are resorting, but if somebody comes back 3 weeks later and searches again, this is clearly somebody who's still searching, right? And what's interesting is this basically continues to trend all the way down, which means that people are searching over almost a month, right? A lot of this could be follow search type people coming back and hitting the follow search. But again, I think of those as people who are basically monitoring the market, right? So this is suggesting that people are doing a lot of searching and they're doing it over a long period of time.
Did you check for a correlation between the price of the item and how many times they go back to search for it?
Yes, good question. That's where I'm heading, exactly. Okay, so yes, exactly. So I love this guy's setting me up. So people search for a long time and they search a lot. So the question is why? Well, as economists, we think there's a reason, there's some return, right? They're getting something out of this. And so the hypothesis here is that they're getting some kind of price savings. This is where I wanted to quantify the cost of search. So I said, how much are people actually gaining by searching for more? And so the way we actually did this was we threw out all the people who were only searching and conditioned on purchasers. So we looked at just people who actually bought something, and then we went backwards in time to see how much they actually had searched, right? So the way I did this is started on that same seed date. I looked at all the people who bought something on Sunday, July 27th, and I further clarified by saying, okay, what people actually bought. I threw out all the people who bought what might be like long tail type inventory and looked at only people who are buying head type turns, right? So items that are on our eBay product catalog, items that have sold more than 10 times in the previous 6 weeks. And the reason I did that is because these are thick markets and I can understand then what the actual going rate is for the item the person bought. So I know like what they should buy, what they should spend in expectation. So I know what like they should have expected to spend, and then I can compare that to how much they actually did spend. Then I connect that with all the search activity, so a bunch of different measures of search, how long it's been since the first time they searched. You know, they may have only searched on 2 different days, but the first time they searched was a month ago. They may have actually searched every day of the month, so the number of distinct days they're looking for, and how many searches they actually did that returned one of the potential items they would have bought, right? So these are just a couple of different ways of measuring search amounts. So then, like I said, I computed the expected price, which is basically, very simply, the average price of the previous the previous 6 weeks' purchases. And then I'm just going to compare the price that the person actually paid to the market price and connect that to how much that person actually searched. So does that make sense? Good. Okay, so this is just the distribution of those components I was talking about. This is the distribution from expected price. So in my sample, some people paid a lot, some people got great deals. This, of course, is what the going market rate is. Most people get something pretty close to what the going rate is. Just a little aside, you notice it's slightly left skewed, which means people will actually put a little bit of effort into getting a bunch of deals, and it's really, there's a lot less mass in the overpaying rate than there is in the underpaying rate, which is a little bit reassuring, but still kind of makes you wonder, did we fail these people who paid too much, right? Maybe, maybe not. They may have, like I said, been lazy and just wanted to buy the first thing that popped up on their screen. Okay, so this is the number of days that are searching here. So this is, most people search only 1 or 2 days, but you can see a right tail here, some people searching for, you know, every day for 15 days. This is how long it's been since you first started searching. Most people only searched, like I said, 1 or 2 days, but then there are whole people who are searching up to 2 months, right? So some people are searching a lot. This is the distribution of how many people searched for that same product over and over again across any number of sessions.
So a friend of mine used to run AOL Shopping, and he spent almost all of his time attempting to keep the sellers from gaming the system by altering their titles and descriptions and everything to make them more attractive to consumers who might pay extra.
Yep.
So can you pull that out of your data? You know, is the fact that dispersion in the upper left, is that driven by more attractive titles, photos,
It's possible. So one thing I did with this, I'm conditioning on everything that's in our product catalog, which means it's basically you can filter on all those traits on the left rail. So these are all items that there isn't a product page for them anymore, but you can basically think of them very homogeneous type goods. And so if you search for like the UPC or the title, you're going to get all of those items. So it's not like, so one potential problem for this would be if somebody came up with a really creative title that matched a particular query that most of sellers hadn't figured out, so they're the only ones who are showing up for a particular
I
set
see a
of
lot of
queries.
that on your site, especially if you're looking for vintage, stuff or whatever, right? There's a lot of heavily, I call it SEO, except it's seller optimization.
So yeah, so there's some of that, and you might wonder that that's part of what this is, and
Mhm.
maybe that's an eBay failure or whatnot, but these are generally very thick markets, and so these are like routers and things like that. These are not like vintage, unique items
You
that
would
are.
think that if that effect existed, it would be smallest in this data set.
Exactly, and I was trying to minimize that effect. That's why we went after this.
I wouldn't be surprised if a lot of the side is like bundles and things like this as well, which we don't always identify well as being bundles versus the core product in the bundle.
Exactly. So one of the DVD titles came with a free bag of popcorn, so maybe that's why it's an extra 25%. People do that, right? So like you don't really know. I'm just generally reassured by the fact that the SKU is left, and there's not a lot of mass up here, but without doing a lot of homework and cleaning up every little data point, I'm not sure what to make of this. So I'm just gonna take it as it is. Okay, so then the first thing to do is just kind of correlate what the price you pay is with how much you did searching. And what you get here is this top pane. And it turns out, perhaps in retrospect not surprisingly, that the more you search, so these are people who searched 15 times, they pay a much higher price than the people who search less. Okay, so suddenly that's really weird. That seems totally backwards. You would think that if you searched more, you would actually wind up getting a better deal. But when you think about this in retrospect, there's a huge confounding variable here, which is, of course, the value of the item in the first place. If you're searching for a TV, you're going to do your homework. You're going to search over and over again. If you're searching for a DVD that's only $10, you might just buy it on impulse, right? So there's what economists call endogeneity. There's this giant confounding variable is that you're going to spend more time and care searching for expensive items than you are searching for cheap items. That just stands to reason, right? Okay, the other reason I went for these thick market items that have well-defined products is because I can then take out the product effect. And so what I do here is basically do a linear regression where I'm basically, actually this is not even linear regression, that's coming next. This is just that percent difference from expected price, right? So instead of the raw price, this is how much of a deal you got relative to the market for that given item. And so now what you see is the people who search more actually wind up spending less, which is exactly what you would think.
I have a question. When you say expected price, what do you mean? How do you say that this guy paid less than the market value? How do you define market value?
So in this case, I'm looking at items that have, in our data, more than 10 purchases in the 6 weeks prior to my seed date.
Okay.
And so the expected price is just the average price over those 10 or more purchases. And so from a cost standpoint, that's the going rate, right? It's the average sales price for this particular product ID. And then I just see, okay, well, what did you pay relative to that?
So how about comparing the dispersion and what people pay to the dispersion in the selling prices? You would think that things that don't actually have the price is dispersed, then the people buying it naturally are going to end up with more dispersed prices, and that might confound.
Yeah, so that's actually a good point. I hadn't thought of that. This is all done at the user level, but if I think about aggregating up for every given product, the dispersion over that product, I could then connect that to the average search level
Yeah.
for that product.
Mhm.
That would actually make for a really cool scatter plot.
Yeah.
Thank you. That is helpful.
So,
That's right, because some items are going to have more search on average, and some items are going to have less search on average, and it'd be interesting to see how that connects with prices. Yeah.
And then
And
complete your y-axis in the lower plot. I don't know what that is. And 2 slides ago, you had it on the x-axis in the upper left.
Yes.
And again, it was confusing. So was it is that 0.15%? Is that 15%?
This is 10%, 5%, 15%, 20%.
Okay. So you said it was a percent that, as a economist,
Yes.
right. So that's 100% and 50%.
Yeah, so just if literally this price divided by the mean, right? So
Yeah.
it was 20% over.
Okay. So that's not obvious, because you said it was a percent, not percentage.
Yeah, it is. It's a ratio. So yes, that's a good point. It's just a straight ratio, and I'm referring as percentage. And you're right. That's actually I should be more precise with that. Thank you. That's actually two really good points. Thank you very much.
You've done a lot of data cleaning. If you hadn't
Yeah.
done the data cleaning, how would that, if you could actually estimate prices for collectibles, for instance, which eBay has a big market in collectibles, one assumes.
Yeah,
What
so
would happen?
I did do this at one point. If you just run the straight data across, so this is actually really easy. You don't need to do this for fixed market products. You can do it for the long tail. And of course, you see this, huge positive thing. People who are looking for fine art that's $300,000 are spending a lot more time searching than the people who are buying the $10 Pez dispenser, right? Like, that makes sense. What actually, I've thrown a bunch of controls, at least just in a simple linear OLS fashion, to try and difference out the product heterogeneity. And I've, except going to these very thick markets where I basically know exactly what the item is, I've never been able to bring this line down to anything that might be reasonably negative, right? So, and the reason for that is you're never fully, in many settings, you're not fully differencing out all of the product heterogeneity, all the confounding factors that you spend more time searching for that particular item, right? So, it's not that it's infeasible, it's just very, very difficult to do in that setting. So, I cheated and went to the easier setting. Okay, so then I could just, oh, please.
Can you go to previous graph? Does the second graph mean that everyone who searches pays less than expected value?
In this setting, yes, because this is actually the way I chopped this plot off. There's a weird data point at 0, right? This is everyone who searched on not just my seed date, but also searched on at least one day prior. So it starts at 1, right? And so for them, they're all getting a deal, right? Because these are, I'm already throwing out the people who just impulse bought. Does that make sense? And so in the paper, I'm going to talk about that in a little bit more detail, but for a visual, that makes more sense. It's weird to think about the 0 day, because that's kind of a different beast. Does that make sense?
Yes, but there should be people who will be paying more than expected value.
Yes, and they're going to be the people who buy impulse day on 0, right? So exactly. And I guess one thing to do is if I included that 0, which would be, of course, way up here, then this green line is going to get really steep, which I think is disingenuous to what I'm trying to do. Does that make sense? All right. Did I see another hand? No. Okay, so this is just the same plot, but for for 2 alternative metrics of search. So one is the number of days you're searching and how long you've been searching for. And again, every time you see the same pattern. There's a positive relationship between how much you search and how much you spend, but then there's a negative relationship once you take out the fact that there's product heterogeneity. So in general, this line here, the slope of that line is a search cost, or more accurately, it's a return to search, which you can impute through a very simple model as a search cost. So I've been teased many times by machine learning people. Oh, please.
Can we go back? Why is the variation in price increasing with time, like for all the graphs that you have shown?
If you remember the histograms, there's just a lot less data out here. So
it's just because the data is more?
N is decreasing, yeah. And I did take a large enough sample that these get really small, but I could resample it bigger. But yeah, N is just decreasing as you go from left to right, so
Right,
the
but
confidence interval is low.
if I join only the rows, then the trend is might actually be a bit different than what the regression line is showing.
Yes, and so in order to do that, I need to do it in a full regression, which is what I'm going to do here, right? So I've been teased by a lot of machine learning people that it's not an economics talk unless there's some form of linear regression in it. This is that slide. There's some truth to this argument. But what I'm doing here is exactly what you're describing, and now I want to do the full weighted regression, because that line was basically looking at weights, just each data point weighted, right, which doesn't really give you the right estimates. This is just a straight OLS estimates. Now it's weighted by the number of observations, so you can actually get confidence intervals out of this that mean something. And basically what you can get here, say, take the simplest one, all of these just include product fixed effects, which is the way you account for the product heterogeneity, just as we've done for the previous differences, except for the one where I'm looking at not the percentage difference, but the ratio of price to expected price. And so here what he basically says is for every additional search, we see a decrease in value of 26 cents. So whereas the previous literature was talking about $10 per search, now we're talking about returns to search in the neighborhood of 25 cents. That kind of makes sense, right? Because if you have to click and search, it's not just like clicking the next button, that takes 10 seconds. It's clicking the next button and evaluating all the items on the next page and figuring out if you want to buy it. At some point, 25 cents, if you're going to gain 25 cents by checking out an entire list of new items, maybe you're going to give up on that.
Don't you think that the transaction value in a hotel search is much higher, and that's why you save $10 compared to 26 cents? Because I don't know what the average transaction is for eBay, but definitely it must be less than hotel bookings.
So that's a good point, and you might argue that the dimensions over which let me refine, I think, let me echo back what I think. You might argue the dimensions over which you have to consider for a hotel are a lot more costly to kind of produce or go through than they might be for just buying some electronic item, right? So in that case, the returns to search is going to be different, like search cost might be item specific, right? So myself, I do not like spending a lot of time picking out clothing, as it can be evident, right? So, but I love doing research for electronics, so I will put in hours of research on the new flat screen TV, right? So user by item specific search cost is a real thing, and I'm ignoring it completely here. We could start going down that route by trying to figure out, basically estimating this for subcategories. I could look at electronics separately than fashion, separately for something else. And you might get into the world of, well, how bad could it be? But $10 just seems kind of ridiculous. 25 cents seems more realistic. So I tend to believe this. And as is evident from the first, the slide we're talking about the literature, people who are only looking at 1 day's worth of search said it was $10. People who are looking at a week's worth of search said like $2. I'm looking at a month and I see 26 cents. So the more data I account for, the lower search costs seem to get. So it's a drastic oversimplification, but you get the idea. Okay, so then these other regressions are basically just getting these in log terms, so I get percentage effects. All of these are about 0.2%, 25 cents for a search event, or about 1% or 75 cents for a day of searching.
So now this duration of the search, is it true, I'm just thinking, that if you search for a day or two, you're searching. If it is more than that, you're not searching, you're just waiting. I mean, you're opportunistic, you can wait. You want to buy a laptop and you know that sometimes they go on sale for 25% off, and every day you're searching, that you're really waiting to see if it hit the price.
Exactly. That's totally correct. And those are two different kinds of costs. One is like I have to kind of defer and I have to wait and monitor. The other is I have to spend time and effort. And we actually look at those separately in these two variables. So one is the number of days in calendar days since you started looking. You may have started a month ago but only looked on that day and then you came back. And the other is the number of distinct days you came to the site and searched for that product, right? And we can put them both in here, and even conditional on one, you see a negative response on the other, which means that both have costs. And if anything, spending a day searching is more costly than waiting a day when you don't search, but they're still there. Did that answer your question? So you're right, there's two different metrics of search, and you can just throw them both in here and get estimates for both.
Is a search, you start over a fresh search or going to the next page, is that search?
In this case, both.
Both.
So yes, I believe it's both. Any search event.
There are some items that if you search for them, you get 1,000 of them, and others you get 10.
Yeah, so this is count of the number of search results pages that are shown that return any item that's in the product ID that you bought, right? So this is every search event. Yeah.
So what's the percentage? So here you say 0.2 to 0.3% savings, but then that's as a function of the selling price, right? So for the hotels, what is the percentage save that the $10 represents, right?
Oh, good question. I don't know. I would have to go back to that paper to check. But you're right. It might be in that range, which again gets to the point of maybe there's heterogeneity in the search costs across dollars, across price points. That's worth thinking about. That's a good point. Okay, so one thing that's kind of new in here, which is basically one of the things we started doing is, okay, who's getting the benefits and who's getting who's getting screwed? So who's to the left and who's to the right on that distribution of gains? One of the things I've just done recently is basically connected the amount of time you spend searching with whether or not you're likely to choose the expedited shipping option. So this is basically a metric of patience, right? So this is, I just kind of correlating roughly how much people search to how much they're willing to hit the impatient button and actually ship their thing overnight. And what we find is a strong correlation between how much you search, strong negative correlation, I should say, between how much you search and how likely you are to actually hit the expedite button, right? So this basically suggests that the patient users are the ones who are doing more searching and the ones who are getting those gains, right? And patience, you may be patient for lots of reasons. You may actually have an intolerant, or you may just not need the item for a couple of weeks, right? Like you're buying something for a birthday gift, you're going to be very impatient and you're going to search for it both, right? So it's not a behavioral term so much as it is in the use case, right? So there's a little bit of suggestive evidence that people who are not a hurry seem to benefit. Okay, maybe that's a
But
little
the
bit
middle
obvious.
graph actually curved up at the end.
Yes, but it's, it's really statistically noisy at that point, right? Like you can't reject anything once you get down to this part. So that's just, there's so few users out there. So it does hook up, but again, that's kind of me squinting, right? Okay, so finally, I don't want to take too much time to everyone tonight. I want to talk a little bit about the experiments that we've been running, or what I've seen at the experiments that run here at eBay. eBay runs lots of experiments. And so you can think of this as a meta-analysis of all the experiments that were run at least in a 6-week period back in 2014, just trying to understand the relationship between purchase volumes and search amounts, right? And the reason I focus on experiments is because then you have exogenous variation in how much people have to search, right? Basically, think about this. I'm actually hoping at this point that there are some use cases, some experiments where somebody in the search team screwed up and made it really hard to find something that they want, right? If you make it really hard for users to find what they're looking for, and basically what you're then going to find is some users are still going to find it and buy anyway, and some users are not. And the drop-off in purchase rates is a kind of a measure of search costs, right? A population average search costs. So if I had changes in how hard it is to find something, and then I can measure how much people search, I get a really cool measure of search costs, right? But while we're doing it, the first thing I looked at was the click-through rate, the click rank. I just thought that this is kind of an aside to the whole idea of the talk, but this is the item rank on the page, and this is the click rate for 91 separate experiments.
So there's 91 separate lines.
There are 91 separate lines. You just can't see them because they're all right on top of each other. Right? So all these search guys are always telling me about the iron law of power of search ranks, and the click rates just do not change as you go down the page. And I have to admit, until I saw this plot, I was always skeptical of that, because what I had always thought is they're just not varying the search costs enough. But for these 91 experiments, there's huge deviations in how much people actually search in the different treatment groups. But this click-through rate is a law of nature. It's just like amazing. So
that includes the screwed up experiments.
yes.
Wow.
This includes the
But
treatment cells. Like,
I guess your engineers aren't very good at screwing up.
Apparently not.
There's a little bit of there's nothing, we don't throw out just random stuff. But it is 91 on top of each other like that. That's law of
So I take it there's a lot of literature out there basically says this is like an iron law, and I'm sold. Like I saw that and I was like, okay, that works.
So what curve fits that?
I'm sorry?
What curve fits that?
This is literally just raw data. This is just a line fit of ranks.
Exponential.
Semi-log.
Yeah, it's exponential.
Oh, yeah. I guess it's a low power curve. I didn't try and fit it. But what's the standard in the search literature in terms of fitting this?
It's like some exponential decay. I don't know what the actual.
I don't know, but it's whatever it is. It's very stationary over search algorithms. Okay, so like I said, this is just kind of the econometric motivation. This is what econometricians call the Wald estimator, which actually goes back to way back in the day. But basically what I'm doing is I'm going to look for 2 different treatment cells. And in one case, I made search really easy, and so people have to do very little searching, and in theory they should buy a lot, right? In another case, Chris screwed up, and they made searching really hard, and people should buy very little, right? So, eBay of course wants to be up here, but as an economist, I'm just really interested in knowing what the trade-off is, what the relationship is, that slope, right? How much more purchases, or how much more are people willing to put effort into buy something when you make search hard. And so what I basically just do is I can take this data point and just plot it for all 91 experiments, which is what I've done here for a bunch of different metrics of search, right? So these are the familiar ones. These are these are not familiar metrics, but this is the last search results page of the item that you purchased. So how many times did you do a search before you actually first saw the item you eventually bought? That's a pretty decent metric for how good are we at guessing what you're going to buy. There's huge variation in this, right? It goes from each data point here is an experiment, right? Which this suggests that these experiments are changing things radically. So you might argue that somebody who basically made it on average for that treatment cell, they had to go through 70 search results page in order to find something they bought, somebody screwed up, right? That doesn't seem like a good thing. What's then really puzzling to me is on the y-axis here is the purchase rate. So this is the number of purchases, right? So this is basically how many people bought stuff. And the fit to all of these metrics is positive, which basically suggests the more difficult you make it to find things, the higher the purchase rates seem to be. This is a puzzle. This is active research. I'm not quite sure why this is. Been trying to figure out, maybe it's a statistical fluke. It's not. Like on the first stage test, these are in fact statistically different from each other, and these are in fact statistically different from each other, which basically means there's statistical evidence that the harder you make things, the more people buy, which just puzzles me. So what I think might be happening here is dynamic market effects. Basically, the inventory is changing in response to how much people are searching in some way that I haven't incorporated into the model. And this just kind of gets to the point of why economics is hard in doing this stuff, in that you have to think about the fact that, okay, I gave 5% of the users a certain search experience and 5% of the baseline experience, but they're both facing the same inventory. So that makes evaluations of these things really difficult, and that might be confounding what I'm doing here. That or everything we know about economics and search costs seems to be wrong. So I'm hoping it's
there's
not that.
psychological effects, though. I mean, sunk costs are things once you've invested, you're now invested, so you're more apt to
Right, so the really scary behavioral problem is if a user's type in, like router, and we show them a page full of dresses, and they just get confused and just keep going until they eventually find what they're looking for. Like maybe actually by making it hard, we're getting people to engage more with the platform and buy. That seems crazy until you think about how all of these like app game developers think about the world, in which case they're deliberately making things hard to get people to engage more in their app, right? So maybe you can gamify search that way, I don't know, right?
Saying we need to sell coin doublers.
Yeah, this is an open question, but basically goes to show that at least as you vary search costs, there's not a clean relationship to purchase intents, and so it's more complicated than we thought. This is just the distribution of those betas over time. So, it's about 8 o'clock, I kind of want to let people go. So let me just wrap up and kind of reiterate what I think I was trying to get at tonight. One is that search costs are actually a lot lower than we think, right? So a lot lower than economists think. They're probably a lot lower than most people think. The behavior in search is just as much about product discovery as it is about price discovery. I think that's pretty obvious from the refinement stories, right? Search horizons are actually really quite long. This is the one that I was really trying to sell here at eBay, but I think it's actually true of a lot of things. And so I don't know if there's any Google people in the room, but I'm pretty sure Google people only look within like the first 2 minutes of a search. For most Google searches, that's probably true, but there's a lot of people out there who are looking for something time and time again, and they might actually be doing the same Google search day in and day out, looking for something different. They're not necessarily navigational, right? So maybe people are looking for things over a long period of time, but then again, maybe this is only an e-commerce question where people are monitoring a market, right? So these are some open questions, but at the very least, consumers are willing to search over long periods of time in order to get some gains. Search engine rankings are important, but how that affects actual purchase behavior is not clear. This is something unusual we don't know about. So basically, the main lesson, this one's really more aimed at economists than it is at the folks in this room, which is that you need an immense amount of data to really answer these questions. So you folks probably already know that, but there's a lot of economists out there who think they can just write some mathematical models and ignore the fact that they're missing the full month's worth of data. And so this paper is kind of pitched at them as saying, no, you need the full picture data, the full view of the data in order to understand what's really going on. Which is basically a way to say that economists have a lot of work to do on search, right? Like the theory guys don't really have models that work for the internet age. They don't have models that can deal with enough of the data that we actually have. We don't know enough about product search versus price search and how those two interrelate in a dynamic setting. So really the punchline is search is complicated, which is probably something you guys already knew. We have models, but they're way off of what they should be. So my hope is that like in a couple of years, economists will actually be able to tell you guys something you can use, right? So I'm hoping that maybe I showed you a little bit how we think about these things, and these are the perspectives, and maybe it gets you thinking, but I don't have any answers on here's what you should go do, except for this, think about the long term, right? Like that's something I think a lot of search people don't do, and economists, of course, typically think about really long horizons. So, any questions about any of that? Any more objections?
If you can go back to the law of nature curve, please. So that is the position of the items on different, that receive those clicks.
Mm-hmm.
Yep, so this is the
But
search ranking. So from
Right.
list 1 all the way down to, I think, 50
So
is the default.
All the ranking experiments and the changes haven't affected the click-through rates, but they're hoping to affect the purchases once the clicks happen. So
Yes.
this will look different if you one day plot the purchase items.
Exactly. So what's interesting is the actual behavioral, like which one I'm likely to click, doesn't seem to change very much. But then what does change is how many searches you do before you find what you're looking for and the purchase rate. So those things are actually changing quite a bit. But there's a couple of things for here. One is this is probably heavily weighted towards people who are doing like one search and then done. Maybe that overweight. Whereas this is looking at people, this is driven, I should say, by purchase rates, right? Because I'm looking at changes in purchase rates. These are people who do a lot more searching. So it may be that if I conditioned this on people who bought something, maybe it looks a little different. Actually, I haven't done that.
In these experiments in which you put the rank, do you actually put, or do you have experiments where there's more data being shown or less data being shown? Because if all you're showing is an item title, as a user, I'll believe that you probably have my best interests at heart, and so I just click it at the same rate, irrespective of whether it's correct or not. I assume, or I might assume that you're probably right at the same percentage, hence the curve. While if you suddenly showed me more data about it, I might be like, oh, that's clearly not what I wanted, move on to the next one, and your ranking.
So I didn't run these experiments, so I can't speak expertly. Maybe Chris can.
If they're ranking experiments, we probably just vary the order that the items
These are
appear.
in fact only ranking experiments for that period. So as far as I understand, the only thing that should be changing is the order in which things appear. But of course, it's not just the order in which things appear on that page, it's which of the recall set shows up on that page, right? So that affects the total, whether or not you click on this page or whether or not you go on. And this is conditional on clicking on something on that page, right? So there are different questions in that sense. Yeah.
Have you looked for any clusters of various kinds of customers? Like, there are people that are not searching every day. They have an item and they say, oh, I can maybe find it on eBay and somewhere else. Well, while you seem to have most of the users are kind of what I'll call professional eBay shoppers.
Yes, so, or at least, experienced, savvy eBay shoppers, right? Maybe not professional. Some of them may be professional. Many of them are probably professional. But, no, so I think an area in which I want to push this research is try to understand how search costs varies for different users for different items. And actually, I know that, of course, there's some users who are going to search very little. These are the professional shoppers, and some users are going to search a lot. These are the professional arbitrageurs, and some people are going to search very little. These are people like me who are lazy and just buy whatever they see. But actually, what I'm really interested in to see how that varies across, within user, across different product intents, right? So like I said, I search a lot for electronics, and I search very little for clothing, and it's just because I hate staring at a bunch of different jeans options, but I really like digging into every little possible detail in a router's, so there's variation in a lot of different dimensions that this is so far ignoring that I think we can do. And I mean, as search becomes more and more personalized, as the algorithms get a lot better, I think that will become more common, and understanding that is going to be important. But I don't have anything on it yet.
Still, I cannot get over the time element. The Google search versus this search are fundamentally different in that in a Google search, although there's a time element, but a lot of searches are just like things change but very slowly. People want to go get an answer. I'm looking for a recipe. Although someone may post a new recipe tomorrow, but if I search a recipe today, I get it and I'm done, whatever it is. I may change it next year, this time I'm cooking the same thing. This search is just a snapshot of what's happening this moment. And tomorrow it is different. And so
You mean the recall set is a snapshot of what the inventory looks like today?
I mean, like the prices change, the new models come in, the things become old. There are, I mean, on and on and on. It's just absolutely a moving market. It's not fixed. I may be looking at the IBM price every day, but every day is different. I know that. So trying to correlate all these searches in a very broad sense, the way that you rank the Google search, it just misses some other elements, in my opinion. It's not.
So you're totally right. Then, this is obviously. I'm an economist. I'm looking at e-commerce, right? So this is an e-commerce search kind of question. And the thing about the long term is really aimed at the e-commerce search. Though I think Google probably deals with a few e-commerce queries, right? So, but you're right in that this is going to matter more, the long-term search is going to matter more for conditions where you have to monitor a market. But I don't think that's entirely what's happening. I think there's a lot of users who are not just monitoring for prices over a given time with the same exact product, but are doing searches over a long period of time. And I don't have any direct evidence on this too. That's really just more of my hypothesis. But I have to, personally, this is anecdotal, data point of one, but I often try searching for something on Google, give up, and then try again later. This happens a lot, like on Google Scholar or something, where I'm looking for papers. I'm looking for papers that are relevant to a particular literature. I search for half an hour, I don't find what I'm looking for. It's not that I give up, I just come back a day later when I try searching again, right? And so if Google were to actually take all of those search queries and string them together and realize that there's stuff going on over time, you might get some information out of this, right? So I think viewing everything as a one-day snapshot of only looking within sessions is still going to miss something even for bigger search engines. That's a hypothesis, but you're right. This work is really aimed at a market where the inventory, or a search setting where the inventory is changing, because that's the way e-commerce actually works. Sure, is that any, please?
Can you go to the next slide? So if you tweak with your search algos, have you seen a difference in how many of the guys don't end up buying? So across all your 91 experiments,
Yes.
have you tried looking at how many your users end up buying? Is that also positively correlated to other?
I think, so the y-axis here is the purchase rate, so it's the number of cookies that buy something. So I think that is what you're describing, right?
Yeah. So, and even in low search queries, you see a positive correlation? So for the users who are making less number of queries?
I guess I don't follow. So have I conditioned on people who are buying something?
Yeah, say you conditioned it on people making only 2 searches and then look at this rate.
So for some of these metrics, right? So this is the first and last purchase page. These are things that are conditioned on whether or not you purchase in order to define the metric of search costs, right? So that's like how far people have to go before they find something they actually want to buy. And then these I'm not just looking at total SRPs. So I guess I've looked at it both ways from the x-axis standpoint, but the y-axis is the percent of people that buy it. There's other ways to think about the y-axis. I could think about how much people spend, like the price of the item they bought, or I could think about the number of items. Maybe I guess you're suggesting I should think about the number of items conditional on buying something. There's just not a lot of people who buy multiple items in the same session. Or actually, this is not the same session. So I could think about it that way, actually.
Okay, so what I'm trying to say is that, say, in one test you have good search quality, in the other one you don't. You have a very lazy user coming to both of them. Is he likely to make a purchase equally in both the cases? So I think
I think what this is saying is that they seem to be more likely to make a purchase in the case where search is hard. Because this y-axis is whether or not people buy, right? It's actually math, but it's basically just the number of purchasing cookies divided by the total number of cookies that show up. So you can think of it as a purchase rate. So this is a probability. One way to think about this is the probability of buying something for a different level of search costs.
okay, and are all of your slides consistent between web and mobile? So if you take the same data on web and then on the mobile, is the data still consistent, the pattern still consistent?
No, so I've only looked at desktop search so far. So these are all desktop search experiments. And I haven't dug into the mobile experiments because it's a little bit of a different beast. But just for simplicity to start, I want to make sure they're all looking at the same thing. So these are all desktop experiments.
So if you can see, are those points like lots of sales, or are those possible outliers that maybe if you drew the graph without those single points, it really doesn't?
So,
okay.
Good question. Okay, so let me go into a little detail. People don't want to go home, that's great. So each of these data points is a treatment cell, right? So it's a treatment experience. If I actually color code all of these into particular experiments where they're all run simultaneously, one is an A, one is a B. So think of this as all the A's and B's, and this is the paired A-B's, right? Does that make sense? Then the slope of these lines should be the same thing. The question is, do these on average have the upward positive slope? And so one way of doing that is to take this. So what this is here is a histogram of the slopes of the test versus control. So basically, instead of looking at 91 treatment cells, which are like 90 different experiments, think about it 45 experiments with test and control. Take the slope between basically the beta shown in that plot, take the slope, the change in probability for a change in the purchase cost, take that beta from the 45 experiments and plot a histogram of them. That's what these histograms are. And so some of these, you're right, it's basically like this is 0, and the ones that generate my positive slope are just like noise, like that's just random stuff that happened. But some of these are actually pretty significant masses in particular directions. If you run, I haven't done the full battery of stuff, there's some new paper on doing these kinds of meta-analysis coming out of Facebook that generalizes an econometric framework, and I haven't done that, but the crude, like, very simple way of testing all of these, it seems to be statistically robust. It does not seem to be a statistical fluke that I got these weird results. that answer your question? Yeah. So I've done a little bit of my homework, but the results are frustrating. Did I see, please?
So you define the cost of search as the cost that you incur by not doing an additional search.
Yeah, so I've been a little, so cost I've incurred by not doing an additional search. That's how the literature has defined the cost of search in the past, yes. Here I did a little something slightly different and inferring that they're the same, which is I'm looking at the gains from buying something. In a very simple model, those two are the same, right?
So you're assuming there is always a gain to be had by searching more.
Yes.
But if these include auction items and if you didn't bid in time, are you losing by waiting? Or I guess in some other domains too, like real estate, if you didn't bid on a house that you liked and you waited too long, you may never come across a house like that again.
So you're right. So in the so this is a different. These experiment stuff is slightly different data sets than the previous stuff, where I basically condition on fixed price type stuff, take out the auctions. This actually does include the auctions, but each treatment cell here is a several week-long experiment. So it's timed in such a way that it's going to include auction effects. So the dynamic effects I don't think are built into this, because I'm matching the purchase to the original search event through where you bid, so where you click through.
Okay, so for e-commerce and hotel searches, for those verticals, maybe then they are different from a real estate search.
Yeah, I take real estate.
Those kinds of
Real estate and
verticals,
cars are
so
not
it's
in
very
any of this
different.
stuff because eBay Motors is
Right.
difficult. It's different. So I take that stuff out. This is just kind of core eBay site.
Right, eBay Motors is very different.
Yeah. Chris, have a question?
Yeah, I was wondering if one interpretation of this is actually that, you know it's going to take people longer to buy more expensive things. If they abandon early, they're never going to have a purchase. There's one explanation could be that we're essentially getting people to come back. So we're seeing more searches, and that's going along with purchase rate.
So you think that the purchase rate is somehow related to price? So I guess one possibility is I've got this time shifting. So I'm somehow shifting people out of the experiment because I've made it hard for them to find what they were looking for at a given price. And so they're saying, never mind, I'll come back.
Sure.
And that actually drives down the purchase rate or something.
No, what if in some cases people are just abandoning before they even get close to the time when they were going to make a purchase anyway? So if you assume there's just some fixed amount of time that you have to wait before you make a purchase, right? If they abandon before that, they never show up here. And
So
the fact that
they don't show up here as a purchaser.
Yeah.
Yes. So yeah, it's possible. Well, so this is why I cut it across 6 different metrics of search, right? Like, it's possible that could happen for one of these, but these are very different definitions of search. So one is how far you have to go before you actually buy something, and then these are basically the total number. I mean, these are really simple. This is just the total number of search pages and the purchase rate. Like, it's actually kind of surprising I hadn't seen this before.
Yeah.
So like, this seems like a really simple kind of thing to do, and the fact that it's positively correlated is really bizarre. Right? Like, just the total number of search events positively correlated with how much you buy when shifted by experiments. Like, that's just bizarre to me. I don't think that falls victim to the dynamic story, right? This is just how many times people hit the search button. So yeah, this is still very much an open question. Controlling for price is something I hadn't thought of, but I have to think about how to actually do that. Yeah.
Just curiosity, please share with this information to the eBay store that sells, or that suppose somebody clicks today for a particular item on a particular eBay store, next week again they click. Do you share that information? So that they will probably offer a price, dynamic price.
So I think you're asking a bigger question about what information about this is available to the sellers at particular times.
Yeah, so that do they game the system?
Currently, I don't think very much.
Okay.
Like, I don't know much about search traffic.
Yeah.
Well, in general, but they do know how many people saw their items, and they know how many people are watching their item. I don't think we tell them. I don't think you know how much people you've shown up as a search item.
No, but people, our really sophisticated sellers do this anyway. They run their own crawlers and stuff.
But they're not going to know how many people are searching. They're not going to know like this. This is impressions, not view items, right? So like some things they don't know. Actually, they're something like Seller Hub, there may be products where some sellers can get to this, but I don't.
Yeah, they can probably, it's not perfect, but we do give like cell data like Terapeak and stuff, and they can pull up historical behavioral data, which might have like.
I don't think there's behavioral data at Terapeak.
Is there? Okay. It's just
Pretty sure they don't have, Terapeak does not have behavioral data. But there might be stuff, there might be other venues through which they can get it, I don't really know. Certainly for the standard consumers that would know. Some things are gonna show up, like they're gonna know if their items were viewed or watched, if they have cameras or whatever. That's just kind of standard eBay practice. Yeah. Please.
No, it's not quite applies to eBay as much, but the cost of making a bad purchase or, looking at satisfaction rate or return rates and things like that there's, have you?
That is an area I've thought about extending this, which is, yes, this is just whether or not you buy given this, but you might argue that these people may have been more likely to buy, but they may be really pissed off that they had to work so hard to find it, and so maybe they don't come back. Or to Chris's point, maybe they actually wind up spending more money, so the return rates might be lower. So the COV and the customer lifetime value, the net impact of this is stuff we still have to work out long term. But that's a good point. We just haven't quantified it down.
It seems you've thrown out all abandoned searches here, but there has to be a cost for abandoning, for searches that were abandoned. The cost of those searches has become higher than people are willing to pay, and there doesn't seem to, you don't seem to have a way to quantify that.
So I switched from data set. So in the previous data set where it's estimating search costs that conditioned on purchase, this does not condition on purchase. So in this case, I'm not throwing out abandoned searches because this is the purchase rate, and it varies, right? So this is actually this is 1 minus the abandoned rate.
This graph on the lower left with the average rank of purchase, you know that one outlier is just like a straight fixed number. Any explanation for that?
Well, so it's a little bit of a scaling issue, right? You know, these all have different scales, right? So if I were to scale on it, it might actually.
Still, even if you scale it, they're all like 24.
Yes. So this might be one. So remember, this is the average one. Yes, but these same things. These are all like 36. So it's just kind of a scale issue.
I think that follows the same way you are telling with 91 cases. Everyone was falling in the same. I believe that's the same.
So the reason I did this for sister metrics is some of these might not change, but you're right that these are not actually changing in a huge range. But one of the things I have checked is these are statistically different from each other. To be precise, the first stage F-stats are enormous. So when you look at the distribution of T-stats for these individuals, so like if I think this is the distribution. So these is not perhaps these are the most noisy, but this still has a powerful first stage, right? So there's still a lot of these estimates may not be moving the metrics a lot. N is so big they are in fact moving them statistically significantly. Does that make sense? And some of these metrics move a lot more. Right?
That was only average though, right? In all those metrics, that was only average. None of the others are.
These are all average. So this is the average over users of the last search page they hit. So yeah, this is all average. But that's exactly what you want because that's what the Wald estimator requires, right? So this is Y bar over X bar, which is actually change in Y bar over change in X bar, which is a Wald estimator. So this is what econometricians call an instrumental variables approach. Any other questions?
Wonderful.
Great. Thank you very much. Did they intentionally turn out the lights?
No. Who thought that digital science could be so interesting?
Turn off the camera.
Have a good day.
I say,